Okay, it's 7:30 and we're going to get started. Welcome to the May meeting of the Johnson Space Center Astronomical Society. I'm Doug Holland, president of the JSCAS, and this is our agenda for this evening. So we're going to do something a little different tonight. Instead of having a main speaker and some other short talks, for this meeting tonight, we're going to have a series of short talks by the JSCAS members, some of us. We'll say we did get one that we did not know of from Chris Randall. We just discovered it a few minutes ago. And Chris, if you're listening, we will include that in the June meeting. We didn't realize there was one more. So my apologies for that. If you have questions or comments during our presentations tonight, you can email them to the email address at the bottom of the screen, jscslive@gmail.com, or you can enter them in as a YouTube comment if you have an account that will allow you to do that. All right, first up tonight, we have Trevor Quinn, who will be bringing us JSCAS Eldorado Mccabe Spring 2022. So take it away, Trevor.
Good evening, everyone. Sorry I'm a little under the weather, but we'll see if we can get through this. Basically, this is from our club trip to El Dorado and then continuing on to Fort Mccabe. That's going to be the last week of March into the first part of April. So let's go ahead and get started. First part of this presentation, we'll show some images from X-Bar Ranch at El Dorado, and then we'll move on to Fort Mccabe. X-Bar Ranch, March 26th through March 30th, 2022. Okay, here's everyone from the club that showed up and various action photos. These are some of the accommodations at El Dorado. Since we were paying members, we had full access to their lounge, which are the upper left and upper right corners. Then they're in the middle of the photo. In the middle photo, there it's just a looking out the back patio across the plains there of the ranch. And then to the left is the outside of the cabin, and then the bottom two pictures are going to be the inside of one of the cabins. And then top center is our little friend that we met. It was a small baby diamondback rattler, which was successfully wrangled by Al Mallory and replaced out beyond the fence line. So no injuries there. So we had quite a bit of wind. So Doug Holland had a bunch of kites with him. So we all decided we wanted to do some kite flying in the afternoon prior to getting set up that evening. And here's a little video of the kite flying. It's just crazy stuff that we get to do. You saw Doug first, and there's Brandon. That kite gave us a little bit of trouble up front, and we had to end up fixing the brace rod using duct tape, which we all know fixes everything. It kept popping out of the kite because the wind was so strong. There's my attempt at it, which didn't go too great either. There's Jerry with a butterfly kite that had quite a large tail on it, so it seemed to be the most stable ultimately. As you can see it flying at some considerable distance there. And then we finally got the other kite way up in the air too. Okay, so I had quite a bit of equipment issues out there, so I managed to only get a couple of images. The first one is going to be the Horsehead and the Flame Nebula in Orion. This one was a 2 hours worth of exposure time, 5-minute subs. This was taken with my Red Cat telescope. And that's the full framed version, the full field of view. And then next is my cropped version with a little bit more processing and brought out a little bit more detail in it. So I was pretty excited about that one. Then I moved on to, I believe, M101. Here's the full field of view, of course, with that scope and camera. And then here's my cropped version of it with some more processing done. And then this is a Milky Way time lapse that I took at El Dorado, and I'll go ahead and start that for you. What surprised me with this is how much of the Milky Way was still visible after the sun broke over the horizon a little bit. So I was pretty interested in that. So then Thursday we headed off. We packed up and headed off to Fort Mccabe. There's the whole group plus the park ranger. And here's some action images out on the field. Getting ready to go for the evening. And here is my M51 that I took. That's the full field. One thing I forgot to do was to refocus after I moved it. So it's a little out of focus, but and I did that one with my C8. And then here's the cropped version. So you can tell there it's how out of focus it was. And then here is just a single still of the Milky Way rising over some of the ruins at the fort. This is just a single shot. And then I went ahead and decided to do another time lapse from the fort going over the ruins as well. So here's that. You'll see there was another group out there that was doing some light painting on the ruins. So you can see that in that lower corner, and then a car went by. So, and that was that. And I thank you. And I'll go ahead and send it back to Doug. Doug, you're up.
Okay, so two questions for you, Trevor. So which imaging camera are you using in your pictures you showed us?
Okay, so the one with the Red Cat and the C8, I was using my Altair 183 MC Pro.
Okay.
And then the Milky Way was just my Nikon with the kit lens.
Okay.
Just on a static tripod.
Okay, and the second question, whose messy room was at the beginning of your presentation there?
That would have been mine and Brandon's.
Okay.
We shared a room to split the cost. So
Okay, good idea. All right, thanks. Okay, thanks for putting that together, Trevor. That was actually a good trip. We had a lot of fun, and kind of the first time we've ever done that. Try to combine two star parties one after the other. It was 9 nights of astronomy, and maybe if we do that again, hope some more people can join us on that one. It was a lot of fun. Okay, so next up from the same trip, I have celestial images from X-Bar Ranch in Fort Mccabe, same trip that Trevor just showed you, but I thought I would share with you some of the images I was able to capture.
Hey, Doug,
Oh, sorry.
Can I interrupt you for a second?
Sure, go on.
Yeah, Brandon, I went through 2 chairs. Thank you very much.
Oh, did Brandon have a question? I missed his.
Yeah, it just popped up. Sorry.
Went through 2 chairs. Very good. Okay, so this is what the X-Bar Ranch looks like. It looks like a ranch out in the middle of nowhere in Texas. Kind of good place to be doing astronomy. And I had 2 configurations. One 200 millimeter Newtonian f5, which is 1,000 millimeter focal length. That's the one farther back. Let's see if I can do my cursor. That's this one over here. It has a coma corrector, and I'm using LRGB filters, and then luminous red, green, and blue, and then a KF A300 monochrome based CCD camera, custom made camera. And on this other configuration, this is a 80 ED refractor. It's a Celestron one, f7.5, which is 600 millimeter focal length. They've got a field flattener, and then it has a modified Canon 450D. So these are the two telescope configurations I was using out there. And I think that might be Mallory's chair over there, and then Brandon and Trevor are way down the field that way. And you can see the electrical cord out here. We ran to be able to hook things up. Okay, so I'll start with my least favorite pictures first. This is the 80 ED picture. This is actually the War and Peace Nebula, NGC 6357. It's in Scorpius, I believe. This is 25-minute exposure with a modified Canon 450D. Nice thing about the dark skies is, you can see all this dust and these dark nebula behind here. And because it's a modified camera, it's going to bring out the reds and the hydrogen, like you can see with this picture. My second one with this configuration, I took a picture of the beehive. I'm not really thrilled about taking pictures of open clusters, but I've noticed, when you have different cameras and different telescope configurations, you find out that they kind of excel at different types of celestial objects. And it's been my observation that this 80 ED and this modified Canon 450D do very well at open clusters. All my best open cluster pictures are taken with this combination. So, my best Pleiades picture I had was taken with this. My best double cluster was taken with this. And then I took this beehive, and it turned out pretty good. You can really see the red and blue stars in here, and it's a beautiful object. You can see this naked eye out at Fort Mccabe and X-Bar. You can just stand out there and just see it with your eyes. But I thought this turned out pretty good with this combination. All right, next one. This is where I moved to my 200 millimeter Newtonian pictures. So this is NGC 5128 Centaurus A. This galaxy, it has characteristics of both being a lenticular galaxy and a giant elliptical galaxy. The lenticular galaxy is a galaxy that looks, len is kind of like the word lens. It kind of has a central bulge to it, and it has a disk, but it does not necessarily have spiral arms. That's kind of the definition of a lenticular galaxy. An elliptical galaxy is just a big round ball of stars that don't really have any particular definition to it. So this particular galaxy is kind of interesting because it's the fifth brightest galaxy in the sky, but because it's kind of low to the horizon, it's at minus 43 declination, it's kind of low to the horizon, it's a little difficult to image. I've tried this one many times and have not been able to get it, but I was this time, and I almost wasn't able to get this because when I set up the telescope, I was near a tree, and the thing just barely skimmed over the top of the tree, so I just lucked out on that one. These are 5-minute sub-exposures. The luminance, 12 of those, the reds are 4, the greens are 5, and the blues are 5. And you may look at this and say, well, why didn't you take more than that? Well, I took a whole lot more than that. But the problem is that just because you take a lot of pictures, they don't all turn out. They either have, a gust of wind blow your telescope, or, something happens or another. And even though I may take, a whole lot more than this, these are the ones that actually were usable. And down here I said spring is galaxy season. When you go out in this time of year, there's just galaxies everywhere. And this is a great time if you want to get out and see galaxies and if you want to try to image galaxies. And this next one is an example of that. This is the NGC 4216 area. This is right at the border of Virgo and Coma Berenices. And one time we were out at Fort Mccabe, and me and Jerry and B were all trying to figure out what the correct way to pronounce this, but according to Nightscape, it is actually Coma Berenices, and we had a lot of different theories about how you pronounce that constellation, but that's supposedly the way you pronounce it. Anyway, so this is 5-minute subs again, and the luminance 17, red 19, green 7, and blue for 11 on this. You might think, well, why are you using 5-minute subs for all these? The reason I'm using 5-minute subs is so I can use the same calibration frames for all these images. So I don't have to take a whole bunch of different flats and different darks and biases. Well, biases doesn't matter, but if you do the same exposure, you can use the same calibration frames for all of them. So you look at this, you can see a bunch of galaxies here. There's this one, that's NGC 4216, and there's these other ones you can clearly see here, all these little galaxies around. But in this next picture is an annotated version of the same picture. So you look at this one for a minute, think about what you're seeing, and then here's the next picture. So there they are. That's all these galaxies now annotated. So this has the NGC galaxies and the IC galaxies here, and it also has the PGC galaxies, which is these really, dark, dim background ones. But in this area, they're just everywhere. It's just there's galaxies everywhere in this field. So this is kind of cool. I did not know that there was this many PGC galaxies in this area, but there are. But once there's Fixed Insight has an annotation function that you can use, and it just pops them all up. You can figure, if you want to figure out, you can play solve it to figure out where you're pointing at, and it actually does a good job of actually identifying and circling all these different objects. 5-minute subs again. You can see luminous 17, red 19, green 7, and blue 11. So as you can see, not very many of the greens survived this one. Just, you saw that we were out flying kites, right? So if we're flying kites, that's a pretty good indication that there's a little bit of wind out there. And if you're using a Newtonian and there's wind, you can imagine that the wind's going to blow Newtonian around, and a lot of your sub exposures are not going to survive because of that. Next one is Leotrio. This is kind of a famous or common galaxy group. This is in Leo, obviously. It's got NGC 3628 on the left. This is sometimes known as the hamburger galaxy, where you can kind of see how it looks like a hamburger. Then M65, Messier 65, and M66, Messier 66 on the bottom. 5-minute subs again, 28, 13, and 12. Okay, let's see. Oh, okay, so this is the Angel Nebula. Okay, so this is NGC 2170, which I think, let's see, NGC 2170, I think is this thing right here. I could be wrong about that. I think it is. But this has got all kinds of stuff in it. It's got dark nebula in it. It's got Vandenberg objects. It's got more NGC and IC objects down here. 5-minute subs again, 27, 7, 4, and 8. Now, this particular area, okay, so here's last fall, I shot this same area in the fall using a 1600 millimeter focal length Ritchie-Chrétien. And that's this image over here on the right. So I was kind of interested in this area, so I thought I want to see a wider field of view than this. And so I took this with a 1000 millimeter focal length Newtonian in the spring sky. And so these are both decent images, but there's some interesting things to note about these, other than, the field of view is very different. One's more zoomed in, kind of, this one's zoomed out, wider field versus narrower field. But one thing is, you look at how much more blue is in the one on the right. You can see these are Vandenberg objects, and Vandenberg is a catalog of reflection nebula, which are blue. But you can see the blue in here. Now, this is the same area over here, but you see it's not as blue. And so you may think, well, it's just processing. And yeah, you might be able to process it up to make it look more similar. But what's really going on here, if you look at the subs from this, the sub exposure, the blue sub exposures from the fall sky have the blue signal is much stronger. And in the spring sky, the blue signal is much more subdued. And why that is because in the fall sky, this is in Monoceros, Monoceros is just east of Orion. So Orion and Monoceros in the fall sky and in the winter sky are much higher in the sky than they are in the spring. In the spring, it's much lower in the sky. So when an object's lower in the sky, you're looking through more atmosphere, and it's going to absorb the blue light, which is why we have blue skies, because the relative size of air molecules versus the wavelength of blue light. But the same reason we have orange sunsets. But in the spring sky, the Orion and Monoceros are much closer to the horizon, and the blue subs are going to be a whole lot, have a lot less energy in them, a whole lot less light than they are in the fall sky. So that's why, and you can see these, I took the subs out and compared them. The reds are fine, the greens are going downhill, but the blues, you can really see a difference between these. So I'm kind of interested in this area, and I'm going to go back again, I think in the fall, and shoot this with my 600 millimeter 80 ED telescope, because I want to see an even wider field of view of the same area. So I'm kind of interested in this. It's a pretty cool part of the sky. I mean, you've got all these dark nebula, you've got reflection nebula, you've got these Vandenberg objects, and it's something that you don't see a whole lot of people imaging, but I'm not sure why. It's a pretty interesting looking area. All right, now I had one more configuration with me. I put a DSLR on the tripod, and this obviously is not Fort Mccabe. This is out in my backyard, but just so you know what I'm talking about, this is just a regular camera. It's just an unmodified camera. It's just a Canon SL3, and it's got a Sigma 17-70 lens on it. Nothing funny about it, just regular stuff on a tripod, no tracking, no nothing. And took a few pictures with this. The first one is on March 28th, we had a conjunction of Venus, Mars, Saturn, and the Moon. And this is an image that shows that. This was taken with that configuration with the zoom lens set at 34 millimeters, 0.3 seconds f4, and ISO 800. This is at X Bar Ranch. And then here's a crop version of that, so you hopefully can see the four objects a little better in this one. So that's something you can do that's really super easy. You can do this with any camera on a tripod. When there's something like this, just go out and shoot it, really easy. And then this next one is another thing that you can do that's pretty easy. This is a time lapse of the Milky Way. And let me see if I can get it to go. I hope it works. There it goes. This is really easy to do. What you do is you take a camera and you put it on a tripod, and this is set at 17 millimeters focal length. These are 20-second exposures at f2.8, and the ISO set pretty high. The ISO is set at 3200. And then you just take a whole bunch of these pictures, one after the other, and then you take them and put them into a video editing software package. I use Corel Video Studio. And you can just put them all together and make a movie out of it. But it's really, really super easy. I've seen people do this actually with iPhones too. So it doesn't even have to be a DSLR. So it turned out pretty good. I've been working on trying to do this. I think next time I'll set the ISO just a little bit higher than I did this time. So let's see. Whoops, hold on. Okay, so you can see these images and other celestial images at my website, which is www.holland-observatory.net. So I have all kinds of things posted there, along with tutorials and other interesting information about astronomy related topics if you're interested. So now next up, we actually have a members minute. This is from Paul Maley. Paul couldn't be with us tonight.
Doug, can I interrupt you for a second?
Oh, yeah, sure.
There was a question that came in. I believe it came in during mine, but I'm going to go ahead and ask to you because we were obviously at the same place.
Okay.
So it says, it appears we were on a hill at El Dorado. How many light domes could we see? I seem to recall about 3. I don't know about you.
Yeah, but
they were small.
They're small. Okay, here's the bottom line on this. El Dorado is pretty dark. There are a couple places you can look on the horizon. You can see some small light domes. That's true. Fort Mccabe, in theory, is actually one level darker. They're both Bortle 8, I think.
2.
Bortle 2. Sorry, I'm backwards. Absolutely right. Thank you, Trevor. They're both Bortle 2, but Fort Mccabe actually is slightly darker than El Dorado. But you can see light domes from both of them. But okay, El Dorado and Fort Mccabe are really different. At Fort Mccabe, you've got people driving by in cars every once in a while, shine lights all over everything. That's a little unsettling. And Fort Mccabe also has some street lights nearby. But if you set up your telescope in the right place so that you have some of the ruins blocking the street lights, you can overcome that. So there's kind of like pros and cons to both of them. Both of them have some light that you can see, some light domes. They're not bad, but they're both, like they're Bortle 2. They're so dark compared to here. It's a good thing. And Trevor, did you want to add anything to that?
I was just going to say another thing to you, Doug. You also mentioned the wind and the fact that we were flying kites and you had to lose some of your images because of it. Just so you folks know how windy it was, Doug's Newtonian on his G11 mount when we were at Fort Mccabe, the leg was lifting up, even though he had it tie strapped down. It was still lifting up off the pad because of the wind. So yeah,
that is absolutely true, and that's why I keep telling everybody when you go to one of these star parties, you need to stake your equipment down. I have bungee cords, and I have 12-inch long landscaping spikes. But let me tell you, you got to do that, or else you're going to lose your very expensive equipment because the wind blows and telescopes blow over. That's the way it is. And
Okay,
Trevor's right. We were out there, and I'm sorry, we were out there, and Trevor was witnessed it. Yeah.
I've got one more question for you, Doug.
Okay.
So why so many luminance subs on your Angel Nebula compared to the RGB subs? Your other images were about the same.
Yeah, that wasn't on purpose. That's how many survived because of wind and other things. But okay, that's true that I took about the same number of subs, but in general, you do try to get more luminance subs than you do RGB subs. And the reason is your luminance subs are what determines your signal noise ratio in your final image. So even though I let them run roughly, I probably did, run more luminance subs than I do RGB subs. Your RGB image can be pretty dirty. I mean, it can look pretty awful. And as long as it's displaying the color, it doesn't matter as much, because once you put the luminance in there, if you got a clean luminance signal, you got a clean luminance, final product, and you put on a dirty, awful looking RGB signal, you'll be amazed how much it cleans it up and how much better it looks. It's truly amazing. Like that specific one, I was looking at the RGB, I was thinking, this looks awful. I mean, I don't know if I'm going to be able to make anything out of this. And when I combined the luminance signal with it, the signal noise ratio just went way down, and it looked a whole lot better.
One more question, Doug.
Okay.
Is there a magic ratio you use for your LRGB as far as the number of subs for each, or
no? You get as many as you can. I mean, I would try to get more. If you have to choose, I would get more luminance subs than RGB subs, but you try to get as many as you can of all of them. Probably a minimum. If you don't get like at least 4 subs, you're not of any of them, you're gonna have problems. If you only have 1, that's not going to work too good. Usually, you got to have some to bring down the noise some.
All right, thank you.
All right, so we have this members minute. This is from Paul Maley, solar eclipse update, and Paul couldn't be here with us tonight, but he sent us something that he'd like for us to read, and here it is. It says, Paul Maley reports that he and Lynn Palmer successfully observed and photographed his 79th eclipse of the sun on April 30th in Santiago, Chile. This was a partial solar eclipse where 27% of the sun was covered. They saw it under completely clear skies. His next plan will be to head back to the Middle East for the October 30th partial solar eclipse, where 38% of the sun will be blocked by the moon. Their viewing site will possibly be in Cyprus or Qatar or elsewhere in the region. So Paul, thanks for sending that in to us. And I think we're going to be hearing from Paul as our main speaker later in the year. So we'll be looking forward to that. Next up, this is great. We have Jeff Stone is going to bring us a short talk on laser astronomy, and we're just thrilled to have Jeff participate. And all of you out there, we would love to have any other members of the club participate in our meetings. It's real easy to do. Anything you'd like to tell us about, we'd love to have you. But for now, we're going to turn over to Jeff and hear about laser astronomy.
All right, Jeff, you have a go.
Okay, hi everybody. This is Jeff Stone coming to you from Kerrville, Texas, and I'm excited to be able to do this. I've never done a presentation in a group meeting like this, so it's kind of unique and fun for me. But I'm going to talk about something I've been doing lately, and it's been very satisfying, and it's doing astronomy with a laser beam. And the really cool thing about that is that it's so easy to do because you don't need a telescope or binoculars or any other optical aids that sometimes are hard to use. You just need, well, you don't really have to have a laser, but it's really helpful. Light pollution really isn't even a problem because there's generally enough stars to get by with to demonstrate to people what you're doing and talking about. And actually, even when there's not as many stars like we have here in Kerrville, we got pretty decent skies. It's not quite Fort Mccabe, but I think when there's less stars, it's a little bit easier because people don't get quite as confused. I mean, you may know where you're going and so on, but anyway, the bottom line is you just watch the sky and see what's going on. And really that's the part of the prep that I enjoy the most. Is I try to go out every evening that it's clear and just look at the sky and see where the various constellations are, and take note of the time, and try to get the hang of where things are going and what you're seeing. And that sub bullet there, learn what events are coming and the basic constellations for the area or a season. That's real helpful, because if you're trying to explain things to people, you want to make it at least sound like you know what you're talking about, right? So since we're talking about lasers, get a laser. I've tried a bunch of different ones. I've tried different colors. I've bought really cheap ones. I've borrowed really expensive ones. And it seems to me that a green 5 milliwatt with a couple of spare batteries is really about all you need. You can spend as much as you want on one of those. As it turns out, the best one that I've ever had, and the one I use all the time, I actually won as a door prize at a JSCAS meeting a couple of years ago. And it looks like all the cheap ones, but for some reason it works really, really well. And let me see, what's it say on here? It says laser pointer. Well, that doesn't help a whole lot. Anyway, one of the tricks to these things is making sure that you use it correctly. You want to make sure that it doesn't go into anybody's eyes, particularly anybody nearby. And that's why it's a really good idea not to just hand your laser over to some little kid who's excited about seeing it. And they get very excited about seeing something like that the first time. And, oh, can I? And you just got to say, no. Or if they seem like they're, going to be able to control it a little bit, and then maybe their parents are there, maybe you can take a chance. But you want to be really, really careful, because it doesn't take but a split second to put one of these in somebody's eyeball and cause some problems. You want to make sure you don't point it at any airplanes. I mean, as tempting as it might be, you see some cool airplane, you go, oh, look at that airplane there, and you point your laser at it. That's bad news, because it can distract pilots, and pilots are on the lookout for these things because the FAA wants them to report it, and they do, and the FAA will follow up and try to find out what's going on, and people have had some pretty serious fines for illuminating airplanes with a laser. Another thing that's worth noting is it takes a little bit of practice. You got to figure out how far away somebody can be from you to be able to see your laser. It depends a little bit on the atmospheric conditions. What you're seeing is the dust or the other aerosols that are in the air. And so going out and practicing and, trying it out is real helpful. Another good thing about it is to start with the big picture. And what I like to do is, generally at a star party, people show up about the time it starts to get dark. And so the sun is still on the horizon, and you can see where the sun is. And then if it happens to be that the moon is somewhere up, you can draw a line between the sun and the moon and explain to somebody that, hey, that's the ecliptic. That's the plane of the solar system. And once people realize that, they just all of a sudden say, wow, that's pretty cool. I've never realized that. Especially when you throw in that that's where the planets are, and that Polaris is, the point that it rotates around. And then you can throw in the sidereal rate and, see if anybody's up on their math, how fast is the sky turning? And it's not really that hard, because it's all the way around in 24 hours. And then again, there's star hops. And so if you know the names of the constellations and bright stars that are up, you can go from, say, Betelgeuse to Rigel, or from the pointer stars on the Big Dipper, and say, hey, if you follow from this star to that star 7 times their distance, then check it out. There's Polaris, and that star is always there. And what's kind of fun about that is, if you know your latitude, which you guys in Houston are not a whole lot different than us here. You're a little bit farther south. I'm right at 30 degrees, and you guys are about a half a degree farther south than that. But so that's how high Polaris is off the horizon. And you can demonstrate that by the little chart that's down there that shows the width of the various parts of your hands. Those aren't college symbols, though some of them might be. The last one is like Decline, right? That's Hawaii. Anyway, if you learn those and remember them, it's really easy to help people understand the sort of distances that are they're seeing across the sky. And then it's also easy to point out that, well, from the horizon to the zenith, that's 90 degrees. So halfway is 45, right? And people generally understand that. So we're really just doing kind of big picture stuff when we're doing this kind of stuff. And then if you know a couple of cool targets that maybe the other guys with the telescopes are using, you can do star hops to those and say, well, you know, that cool thing that you saw over there, well, that was Saturn, and there it is, and it's about, you know, this far from wherever, and so on. I've heard a lot of astronomers get kind of excited about how far away things are. But, you know, the distances that we're talking about when we get into astronomical things are so far. I mean, however many million miles or light years or whatever, people really don't kind of relate to that unless you take some time to explain it. But more often than not, if you just try to get them to sense the rhythm of what they're seeing and what direction things are moving and so on, they can kind of internalize that and take it home. One of the really important things is mentioning that planets don't twinkle normally and stars do. Of course, when you get to the horizon, or if you have a real still night, then that can be a little bit confusing, but generally that's a good thing that people don't know about and you can mention. And then one other thing that I want to mention is that, you know, the Big Dipper, that's not a constellation. That is an asterism. And likewise, the Seven Sisters and, you know, a couple other things. And you need to make sure that people understand that that's, you know, there's 88 constellations, right? And so you need to know that the difference between those as you're talking about them. One last thing I want to mention is that this weekend, Sunday night, total lunar eclipse. It should be a good one if it's not cloudy. It's going to be a supermoon, so the moon's going to be closer and appear larger than usual. It's Sunday night, May 15th. You can see the times there from about 9:30 to 1 o'clock in the morning is a total thing, but the totality runs from about 10:30 to almost midnight, with the maximum a little bit after 11 p.m. I ran across this time and date website. It's really cool. If you haven't seen it, go there, find the eclipse pull down, and you can go through there and see some really cool stuff. On this next slide, I'm going to show that these are some screen grabs of the animation that they run on how this works. And if you look at the at the curves that are going around the moon, you can kind of see how that's the round part of the shadow that's covering the moon, and this animation really shows some motions that you otherwise wouldn't see. And as it turns out, here in Kerrville, about an hour before, let me go back one slide. Yeah, about an hour before the partial phase begins, the space station is going to fly over at 86 degrees elevation. So it's going to go straight over Kerrville. We're going to have a great pass. That one's not quite as visible from Houston, but I think it's like 35 or 40 degrees, so you'll be able to see it. But just another fun thing that's going on this weekend. I hope everybody gets to see it, and if you have any questions, I'm happy to try to answer them.
Okay, Jeff. What other laser colors did you try?
Well, I have tried red and purple in addition to the green, and a couple of different greens. The greens are, I think they're all, was it 540 nanometers or something? But the red and purple just don't show up nearly as well to your eye as the green does. I don't know if it's because of the color or just it was a not so high quality laser. But those are the colors I've tried.
Did they work at all?
Well, not really. They work for illuminating things that are terrestrial, like if you shine it on a car, or the fun thing is the street signs, right? That glow so much. But really, for lighting up the little particles of dust and aerosols in the air, the green is way, way better. The other ones aren't even worth the trouble.
Okay. And then here's a little something not specifically about your presentation. I understand Kerrville's a pretty decent little place. Do you ever get any unsavory characters stopping at the IHOP?
Well, the only time I've been to the IHOP, I was quite stunned to see these kind of scraggly looking guys kind of hunched over their breakfasts and there was something about one of the hats they were wearing. It had the space shuttle on it, and I went, well, wait a minute, and I looked again, and sure enough, there were Doug and Trevor on their way home from the Fort Mccabe and the El Dorado. So it was great to see you guys. Really enjoyed it, and I highly recommend anybody coming to the Hill Country, get a hold of me. I'd be happy to show you what's going on around here. It really is a beautiful place.
All right, thank you. I'm going to switch to Doug. Doug, you have a go.
All right, thank you. And thank you, Jeff, for doing that presentation. Like Jeff said, he's out in Kerrville. We're in Houston. So if you're a JSCAS member, and doesn't matter where you are, what city you're in, you can still participate in our meetings since we're doing them all online. So thanks again, Jeff, for doing that. All right, we have two presentations from Chris Wells. He has one called One Shot Color Narrowband Imaging, and he has a members minute about a land, sea, and sky event that's coming up. So with that, take it away, Chris, our Vice President.
Okay, Chris, you have a go.
Awesome. Thank you, Doug. Thank you, Trevor. Okay, this is something a little bit different, something that I've been trying really last year. I got into something called, not on-shot, there's a typo right there. It's meant to be on-shot color, one-shot color narrowband imaging. So for those of you who've got like a DSLR camera or one of those CMOS astro imaging cameras or CCD imaging cameras that have a Bayer array in there, on those cameras that allow you to take color images, you can actually convert those kind of cameras into a narrowband imaging setup and take images like you see here on my introduction slide. So when it comes to imaging, location is everything, and sometimes we don't get to go to Fort Mccabe or Aldorado's Star Party or those or Kerrville even, and it becomes a bit of a challenge to image items, and that's where one-shot color narrowband imaging comes into play. This is a couple of apps I like to use in terms of showing how bad my light pollution is on where I did some imaging last year. I'm in League City. I use a Clear Outside application on my Android phone, and it shows here that my sky quality is a Class 7 Bortle sky. Another one that I think is probably a bit more accurate is the Astropheric application, and it shows you there, we see the ring at the center. It shows you that my sky conditions are actually even worse than what the image on the left says. Is that actually a Bortle 8 sky. So I from that I'm saying I'm probably somewhere in the middle between a 7 or 8 sky, which makes imaging at home really a challenge. And that's where filters come into play. And there is a myriad of filters that you can choose. And it gets quite complex to try and work out what filter does what and why you would use it. You can have broadband filters, narrowband filters that are separate filters that you combine images using various image processing techniques, and have filter wheels that contain them. And sometimes you have ones called one-shot color, or OSC as the acronym they give to that. And that's what I'm interested in here today, is one-shot color. And with this myriad of filters, you have to get selective on the type. There's a lot of different manufacturers. I'm actually a spec shopper. I love to look at the various specifications of different filters out there. And the ones I've put here in this chart that I created is the one called from Optolong, the LE Enhance filter. There's an Altair tri-band filter, an Altair quad-band filter. OPT have a brand called Triad and Triad Ultra. So if you're going to get into one-shot color narrowband imaging, which one do you use? Well, I haven't tried them all. I've only really tried one, but I do like to look at the different specs to see what the difference between them is. First of all, in the hydrogen beta and the O3 spectrum, so hydrogen beta, O3 spectrum, down here, you get a band pass specified for each of the different types of filter. Now, obviously, the narrower the band in terms of nanometers, the less light pollution you let in. And so if you took a look here at the Altair tri-band, it's quite a wide band pass, a 35 nanometer band pass. So it's going to let in more light pollution than the other end of the spectrum, the Triad Ultra, which is only letting in 5 nanometers for hydrogen beta and 4 nanometers. So this is like really, really tight, narrow band pass. And therefore, these are the kind of filters that you can use in full moonlight. They completely eliminate everything except for what you're looking to image, such as sort of hydrogen alpha emission nebula, that sort of thing. So you see that they've specified slightly differently. And generally speaking, the more narrow band you get, the actual more cost to the actual filter itself. So, you know, just by this end of the spectrum, they tend to be around about $200 to $300. But when you get to the triads, those get up into $1,000 and up for those kind of filters. Anyway, so what I managed to do is put this chart together of the different manufacturers, the different wavelengths, and the different band passes for each of the filters. I also looked at thickness of the different filters as well. That can just out of curiosity, some of them are only 1 millimeter thickness, some of them are up to 3 millimeters thickness, and that can change your back focus position of getting an image in focus. Also, I sometimes like to look at transmission rates, and some of these aren't published, some of them are. Obviously, the more modern codings that they use for narrowbands, the higher the transmission, and then the brighter the object. So there's many options. I happen to choose the Altair tri-band because they keep it in stock at Land, Sea, and Sky, and it's ideal for, I think, my Bortle 8 skies. Okay, another thing about choosing the right filter is the focal ratio itself. If you got into hyperstar imaging, which is probably the fastest imaging setup you can get, and I've done this with a C11, operating at f2, is that you need actually a wider band pass in order for it to work with the hyperstar system. The actual light fall off, an image or spectrum shift that you get with a hyperstar setup is with the filter characteristics means it takes it off band. So you can have a signal, you can have photons coming into the filter, but they get shifted off of band because the light cone is very, very steep with a fast optical system. So one of the things that the hyperstar users say is, and this comes off of the Starazzona website, they say telescopes with focal ratios faster than f2 will move the transmission off band, and they recommend that you have a 10 nanometer band pass. So that's why in this chart, I like to look at the band passes and how appropriate they are for the kind of imaging setup you've got. So if you get down to 4 nanometers, are you going to really use that filter that costs $1,000 on a hyperstar setup? When I think hyperstar is more, it would go off band. And when you go off band, the actual sensitivity or the transmission rate of the filter itself drops. So there's trade-offs with everything on this hobby. And that's just one of the things that I like to look at, mainly because I've imaged with a hyperstar and I've also imaged in slower systems as well. Okay. Another little point of fact is the thickness. The actual thickness itself. I kind of had fun with this and went back to school again and looked at Snell's law and how the convergence of the light cone itself, it goes through a plate metal glass such as a filter, and the thickness of the glass itself makes a difference in where the image comes into focus, and it can actually give you some benefit. So if it's a 3 millimeter thickness filter, you've actually increased your back focus distance by about 1 millimeter. If you did the maths of Snell law, it works out about to that. It's just playing around with some old ideas from school there. So anyway, this is the narrowband filter that I chose. So one shot color has a nice little chart here showing you the different bands. So with the tri-band, it combines hydrogen alpha into the red zone and hydrogen beta and O3 into the green and blue zone. And you'd use the tri-band in severe light pollution situations. That's me, Portal 8. And you'd use the quad band in moderately light pollution. The quad band also has the S2, the sulfur 2 band as well included. So it's naturally a wider band and therefore can let in more light pollution. This is the one that I used. And these are some of the images that I did take in League City. This was using an FSQ 106 and an ADIC 460EX one-shot color astro imaging camera. Once again, I'm using the Altair tri-band, and this is M17, the Swan Nebula, and you can really see the amount of illumination you're getting for hydrogen alpha emission nebula. It goes all the way to the edge of the image. It really does bring out the image in a way that you can't do without the narrowband filter. So this was probably somewhere in the region of about 2 or 3 hours of imaging. I tended to use about 5-minute sub exposures, and yeah, really pleased with those results that I could actually do that at home, and would have liked to have gone for the Fort Mccabe and West Texas in those Bortle 2 skies, but when you can't, you can still do this at home. Okay, here's a close-up image here of the Horsehead Nebula. Just another example of something I've managed to do at home. I really didn't think this kind of thing was possible at home, but with narrowband imaging, it is. Another example of the Bubble Nebula. Once again, similar setup, similar exposure times, around somewhere between 2 and 3 hours. Thing about the Bubble Nebula is that I've never ever been able to see the Bubble Nebula at home visually, even with an 18-inch Dobsonian, but it's so easy to see when you actually image, particularly in narrowband. Another example, Trifid Nebula. Another example, Lagoon Nebula. And you just get so much more of the emission nebula showing using narrowband imaging techniques. Oops. And lastly, you can sometimes use these filters as well on galaxies. This was just more of an experiment than anything else. This, of course, is M31, the Andromeda Galaxy, and taken from Bortle 8 skies. Just look at those dust lanes. You can really get some detail to come out imaging at home, even with Bortle 8 skies, using narrowband imaging. So that concludes my presentation. Any questions out there, Trevor?
Hey, Chris. So with the supply chain shortages, are these filters readily available?
They actually have been. Supply chain was a big issue with telescopes, with filters, with most things astronomy related. Sewing machines were a problem, I understand too. Also, weightlifting equipment was hard to get. I think a lot of the supply chain problems have lifted. Many of you know that I play at the telescope store, the local telescope store, Land, Sea and Sky on Saturdays, and you know, the products are now becoming more and more readily available. So yeah, these products are available, and if not, the order time is not the problems that it used to be. So supply chain is definitely improving greatly now.
Okay, approximate cost of the 2-inch filter?
I should know that, and I don't. I think it was somewhere. I think it was about $250, somewhere around that for the Altair ones. The one that I used.
Okay, I think you can continue on.
Awesome, thank you. Okay, and last up, just one more members minute. A little statement that Land, Sea, and Sky, that's our local telescope company on Richmond Avenue here in Houston, is having an event on June the 4th called a Dobapalooza. Hopefully I've pronounced that right. It's a sidewalk astronomy festival. So there's going to be Dobs and donuts between 10 a.m. and noon. So come along and see everybody at the store that day for Dobs and donuts and coffee as well, Constellation Coffee. It's going to be participated with some of the local astronomy clubs. JSCAS will be there. Houston Astronomy Society will be there. So there'll be a sort of a membership push there, flyers, and anyone who's interested in any of the clubs. It'll also go into the evening up to between 4 and 7. There'll be moon viewing on the sidewalk with Dobsonians during the early evening there as well. So do come along and see us. If you haven't been to our local telescope store, Land, Sea, and Sky in a while, you'll notice that it has a complete new showroom. It has a telescope alley. It has a binocular bench. It has a microscope corner. Has lots of astro imaging publications on the wall. It's changed completely if you haven't been there in the last 7 months. I think 7 months ago they changed the store completely. So do come along and see the folks there on June the 4th. So that, as I say, that's going to start at 10 a.m. there on Saturday morning, June the 4th.
All right, thank you, Chris. Okay. All right, Doug, back to you.
All right, thank you for that, Chris. That was very interesting. I wanted to make a correction earlier in the meeting. I mentioned the name of a book. The name of the book is actually Night Watch. I think I called it something else. But if you're ever trying to figure out how to pronounce different celestial terms, the book Night Watch actually has a nice section in it that tells you the pronunciation of constellations and planets and things like that. Interestingly enough, we actually had 2 astronauts that came and talked to us, and one of them pronounced moon of Saturn as Enceladus, and the other one pronounces as Enceladus. So yeah, if you're around the astronomy community for a little while, you'll find out that you'll hear a lot of different pronunciations of the same words. So there you go. Next up, we have, this is David Havilland, Star Party News. David could not be with us tonight, so I'm just going to cover this real quick. Past events, we had Texas Star Party at Prude Ranch at the end of April and up to May 1st. We had several members go out to that, and I think they had a pretty good time. It sounded like the weather was pretty good, and they had some good success. The June 4th event that Chris was just talking about at Land, Sea, and Sky. July 9th coming up, there's going to be an outreach event at the Hack Winery. The Magnolia Golf Course wants us back. There may be an event in August coming up. We did that recently. It's a pretty good place to go. Nice place to give you free food, and it's a pretty decent place to have a star party outreach. September 2nd, another Hack Winery event. October 20th to the 22nd is Fort Mccabe in the fall. October 28th will be the Houston All Clubs meeting. October 29th, the Astronomy Day at the George Observatory, which will be good since we haven't done that for a couple of years. And then November 4th, a Hack Winery outreach event. So that's what's coming up. All right, Jeff already covered this. So just a reminder, the lunar eclipse is Sunday, just a couple days away, maximum at 11 p.m. You should be able to see it from where you are. I've heard that the weather is going to be good, at least here where we are, so get out and see the lunar eclipse. Before we go, I'd like to say a couple words here about, we lost one of our members in April, Hernan Contreras. And Hernan has been a longtime member of the JSCAS, and he was known for sharing his love of astronomy with people at our public star parties out at Fort Mccabe. He also made significant contributions to our meetings. He used to do a What's Up in the Sky segment where he would tell us all about what's coming up, celestial events that are coming up in the near future and things we had to look forward to. And Hernan also had this segment he called Astronomical Oddities. And somehow he would always come up with these weird, odd things that he would tell us about something usually in the history of astronomy, about some weird thing he had found and share it with us. And this was always a real highlight of our meetings. So Hernan has made a significant contribution to the success of the Johnson Space Center Astronomical Society, and we are certainly going to miss him. Next meeting is on June 10th. David Havilland will be bringing us EAA, Electronic Assisted Astronomy, at the George Observatory, and we'll have some other DIY astronomy topics. So thank you very much for joining us tonight, and I hope you can join us again in June. See you then, or talk to you then.